In this video, we are going to be talking about substitution versus elimination reactions. For some reactions, it is very clear whether the product is a product of an elimination reaction or a substitution reaction. But sometimes it is not as clear, and both reactions will be in competition with each other and both products will be produced. So in this video, we are going to learn how to determine what the major product is. There are 3 steps to determine the major product. Number 1 is to determine the function of the reagent, whether it's a nucleophile or a base. The second step is to analyze the substrate and determine the mechanism. And once you've determined the mechanism, then you can consider any regiochemical or stereochemical relevance. And so once you find out what the mechanism is and once you've analyzed it, and you're confused on what the product should be, but you know, okay, this is an E2 reaction, but I'm not sure what the products are stereochemically or regiochemically, there are videos over each specific mechanism, and so I would definitely go back and look at videos over regiochemical and stereochemical relevance on the specific mechanisms. For determining the function of the reagent, which is step 1, there is an entire video on determining whether it is a nucleophile or base. And this is super important because this will help you determine whether it will be elimination or substitution. So now we're going to talk about if our reagent is a nucleophile only. Examples of this would be a chloride ion, bromide ion, or anything with sulfur. And in this case, it will be 100% a substitution reaction. If you have a nucleophile only, it will be 100% substitution. There will not be any elimination products in there. So we know that it will be substitution if we have a nucleophile only. So the next question is to ask ourselves, does this precede SN1 or SN2? And so that is when we look at the substrate. So if we have a primary substrate, it will always be SN2 because this is kinetically favored. Example, if we have a molecule that looks like this, and we have our leaving group right here, this would be primary, and you know that it would be an SN2 reaction. For a secondary, so say this bromine is not here and it's right here, this would be a secondary substrate. This will produce both SN1 and SN2. And then if you have a tertiary, you know that it would be SN1 because SN1 always leaves behind that carbocation, and the carbocation is most stable in a tertiary position. So now we're going to talk about if we have a base only. And the example I put for this one is a hydride ion. And this will be 100% an elimination reaction. So notice that all of these are E2 reactions, even if the substrate is primary, secondary, or tertiary. This is because usually with an E1 reaction, the base is usually a weak base. And so in this case, we're talking about if it's a base only, and we're assuming that it's a strong base. So that's why it is E2 only for all of these. Now we're going to talk about whether it is an elimination or substitution if the reagent is a strong nucleophile and a strong base. And so this is a situation where both products will occur, and we need to decide what the major product is. So if we have a strong nucleophile and a strong base, and we have a primary reagent, SN2 is going to be the major product. And again, this is because of the kinetic effects. SN2 always favors a primary substrate, and E2 would be the minor product. For a secondary substrate, E2 would be the major and SN2 would be the minor. And this is something you just have to memorize. And then for a tertiary substrate, an E2 would be favored. So notice that there are no SN1 or E1 reactions in here, and like I said on the last slide, that is because those usually favor weak nucleophiles and weak bases. So now we're going to talk about if we have a weak nucleophile and a weak base. And so see here we have the SN1 and the E1 thrown in here, and that's why. So if we have a primary substrate, this is going to be the exact same reason for all of the other ones. SN2 kinetically favors a primary substrate, so that is going to be the product for that. Even though it would be a weak nucleophile, SN2 still wants that primary substrate. For a secondary, it can be SN1, SN2, or E2. There's really no E1 products for this one. It's just not favorable, but you would have all three of these products. For tertiary, it's going to be SN1 and E1, and this is because both of these reactions leave behind that carbocation, and it will be most stable on the tertiary position. For SN1 though, if you have a secondary substrate, it will leave behind that carbocation on the secondary position, but you can have carbocation rearrangement, whether it's a hydride shift or a methyl shift, so that's definitely something to be aware of. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.